All right. Wrong desktop to stream. What's happening? Okay, there we go. I am just checking some settings here. It seems strange that this stuff changed. Oh well, I'm not going to worry about the video at the moment. As long as the stream is going okay, I'm fine with it. All right, so let's go into 2024 Swift. Let's just prepare 12 to go into day 12. And I am going to probably jump back to day 11 because I feel like I was pretty close. But let's get into day 12 first and see how far we get. All right, Advent of Code, day 12. Garden groups. Why not search for the chief historian near the gardener and his massive farm? There's plenty of food. Historians grab something to eat while they search. You're about to settle near complex arrangements of garden plots when some elves ask you if you can lend a hand. They'd like to set up fences around each region of garden plots, but they can't figure out how much fence they need in order to grow how much it in order to order or how much it will cost. They hand you a map, your puzzle input of the garden plots. Each garden plot grows only a single type of plant and is indicated by a single letter on your map. When multiple garden plots are growing the same type of plant and are touching, they form a region. This 4x4 arrangement includes garden plots growing 5 different types of plants, A, B, C, D, and E, each grouped into their own region. In order to accurately calculate the cost of the fence around a single region, you need to know what that region's area and perimeter. The area of a region is simply the number of garden plots in the region contains. The above maps type A, B, and C plants are in a region of area 4. The E plants are in a region of area 3. D plants are in an area with region 1. Okay. Each plot is a square, so it has 4 sides. The perimeter of a region is the number of sides that garden plots in the region do not touch each other. Okay. The type A and C plants are each in a region with perimeter 10. The B and E plants are each in a region with perimeter 8. The lone D plot forms its own region with perimeter 4. Okay. I think this is like a flood fill type of algorithm. Plants of the same type can appear in multiple separate regions. Regions can never appear within other regions. Okay, that's good to know. The above map contains 5 regions, one containing all of the 0 garden plots, and the other 4 containing a single X plot. Okay. Due to modern business practice, the price of a fence required for a region is multiplying a region's area by its perimeter. Total price of fencing is found by adding them all together. All right, let's jump into it. I will start by doing a test func for part 1 example. We're going to end up needing to parse these, so let's create a test to parse it. So I expect these to be a grid. If I can do day 11, let's do try day 11.parse input. Should be a grid. And then we expect that grid at point 0, is an A. Grid at point 3 is a C. That's probably good enough. And this is going to be, let's go over to day 12. That should give me a grid of characters. We can grab that from here. No, that's separated by white space. I think what I would do, if we're going to use parsing for this one, which we could certainly try, it's going to be a little bit different. So this is going to be a line is going to be many any character. No. Character.parser. Let's see, parsing dot, what do we have in here? Take a look at the, so they have int parser. Let's look at the source. Parsers, various operators defined as extension of parsers implement their functionality. What is parsers dot? Okay, that's not what I really want there. Oh, here we go. Character set. I don't know if this actually does what I want, but if I do character set, character, let's do alphanumerics. That gives us that with a separator of new line. So that's many characters. And then if I do parse input, what does that give me for line? That gives me an array of substrings. I'm not sure how to do what I'm trying to do, and I know how to do this without using a parser. I don't remember what day it is, but one of these we have a grid where we are already parsing. Here we go. This one's, I suppose, a decent starting point. Okay, so we're going to have a single grid. We don't need that. String.element, which should be character. That is, yeah. Let grid is a grid of character. That needs to be day 12. Okay, let's go over to day 12. And let's just do one more expectation that grid.rows.count is equal to 4. All right, so our part 1 example, we need to get a grid, and then, well, we just need to grab our results, which is going to be try day 12 dot part 1 input, and we expect that this result is equal to 140. Okay, so this is result equal 140. Let's do public static func part 1 input string throws returns a string. I'm gonna get rid of Copilot because it's conflicting with what I'm trying to type here. Okay, so this test is going to fail because we're just returning an empty string. I want to do a smaller test which allows me to inspect the grid in order to determine what the different regions are. Once I've determined the regions, I think that what I will end up with is a public struct region. These actually don't need to be public because I'm just doing testable. Right, that's, yeah, okay. Our region is going to have maybe a character that defines that, and then it's going to have a points, which is going to be a set of points. And somehow I would need to identify a given region in the grid. So for instance, if I do an extension, on grid and I say func give me all the regions, this should return to me a set of regions that can be hashable. This doesn't have to be a set, it could be an array. I don't know if I need that yet. Okay, so if I go back to the test, I want to create a smaller test that is extract regions. I want to, I'm going to say detect region at point. So given this input and the grid, tried a 12 part parse input. I want to say grid dot detect region at 0.00, and I expect that to give me these 4 points. All right. Detect region at point. We expect this to give me, you should always get a region. So this region, we're going to say expect that the region equals a day12.region with character and points. Character is going to be A. Points is going to be a set of points. So we'll do a set with 0.00, 1, 0, 2, and 3. We can do self point to get the character, and for now let's just return a region. Okay, and that'll be points. This needs to be grid of character. All right. So this is going to fail because we don't contain all the points. We only contain the 1 point. Okay, so for each we have our neighbor function from the previous, from day 10. This one is getting grid.neighbors, and neighbors is in, yeah, neighbors is just without diagonals. So we can use that to get the neighbors. Let's get out of here. So we can do points to visit is a set of points, and that's going to start off with point.neighbors, grid.neighbors. Wait, why don't we have grid.neighbors? We should. For this point. Neighbors for point. Oh, that's self, duh. Okay, we also want to have a visited set, because multiple, like let's say we have an L-shaped one. If we have an L-shaped one, then 2 of the cells will have the same neighbor, and we don't want to visit it again if it's not part of the set. All right, while points to visit is not empty, we are going to grab an entry off of there. So we're going to say points to visit. Can we pop first? Let's see. While let P equals points to visit dot pop first. If we're going to say visited dot insert P, if P's is if self at this P is our character, then we need to add that to our region points. Region points dot insert P, and then we need to add all of our neighbors to points to visit. And so we can say for neighbor in neighbors for P, where self at P is equal to, I guess we just need to add all the neighbors. Points to visit, because we're already checking here. Let's see, can I do plus equals on an array? No. I can do set of neighbors for P. No, I can't. I would have to do union set of neighbors for P. And it's strange there's not like add more than one to a set. Where not visited dot contains n. So we're not going to add it if we've already visited, and then we're going to add n here. That's insert. So we're going to keep going through until we've detected the region at that given point. The thing that I have here, once I've visited the point, so that'll detect the region, and then basically I will just scan for the next point that's not in any of the regions so far and find one there. But I feel like this is where we could start a new process to detect that one, but then this one would exclude all of the points that are in existing regions found so far. Hey Samuel. Good morning / afternoon. Feels weird to say good afternoon when it's morning for me, but so the thing that I'm curious about here is how many points did I actually touch during the iteration of this one? I touched these two rows, which I suppose is fine, but I'm gonna want some way of tracking like all the regions I have so far. So for instance, if I go into B and I want to detect, I'm going to be searching A even though A is not in it. I guess that maybe that's fine. So I guess this just gives me the next point to check. So let's do starting point is 0.00. Just lost the last hour of trying to record bass. Oh, dang. That sucks. Like you were playing and realized you weren't recording, or you're just like spending time trying to get a recording? Didn't check the bounce, but also didn't say the project because I thought recording would be enough. Oh, yeah. That sucks. But chalk it up to practice. Okay, so I'm going to have my regions here. The thing that I'm curious about, though, is how many regions we're going to end up with. So I can detect a region. Fortunately, it was just to send a teacher. So you're taking bass lessons? How do I know I'm done with the regions? When I visited all the points? Nice. I had guitar practice last night. Or band practice. We are playing a show at a new venue on January 3rd. And because of the holidays, it's tough to find time to practice. I'm not sure what I want to do here. I just know that I need to loop. So this is going to do regions dot insert a region or append region, detect region at point. We can do start point. That's fine. Start point. Then I need to find the next start point. So I'm going to, I suppose, check all of the region points. Sorry, all of the grid points. I think I should just do that and then just make sure that it's not in any of the region set of points. Do I have all points? I think I had an iterator for a grid in day 6. That's what I feel like I just want to make this public. So if I go over to grid, let's just paste that here so that I can iterate and get all points and elements. And so I can say for point, I don't care about the element, in self. At this point, I need to say guard that none of the regions, regions dot all satisfy, not $0 dot points dot contains point. Else continue. This would be nicer if I had all of the points for all the regions every time rather than iterating. So maybe I have another set of visited points. And then I say guard not visited contains. Else continue. Then I can get the region, which is going to be detect region at point, and then visited dot form union with other. I think that's what I wanted before, because that actually takes a sequence. Okay, and at this point now I have a bunch of regions. I can just return the regions. So that's detect regions at point. Let's just write another test that says detect all regions. And that's going to be regions. Let's make sure we have 4 regions. And that region's 0.character. Why is that not showing up? Regions 0. There. Character is A, and then 1, 2, and 3 are A, B, C, and D. Oh, and E. That should be 5. So I don't need thread 6, fatal error, index out of range. Okay, so I didn't find anything. I don't need the start point. Yeah, guard not visited contains point, so we don't contain our first point. Return regions. Let's see what happened here. Oh, regions was never mutated. Wow. That'll do it. All right, so now we have all regions. Now I need to be able to get the sum of a given region. Not sum, but the perimeter. So the perimeter is going to be an int, and also the area is going to be an int. So let's start off with perimeter. This is going to be test func perimeter. Let's do struct region tests. Let region is a region. Then we can do an init. Well, I may want to test more than one. That's fine. I'll just do this. Test perimeter. So if I let the region be a region, day 12 region, let's do 0 for now, so we can figure this out. All right, so the points here are going to be a set of 0.00. So we're going to do the same A. 1, 2, 3. Okay, so I feel like this solution is going to be pretty terrible for the real input. I don't really know. I feel like maybe it's better to find edges and then detect loops or something, but I don't know. Okay, so if I have this, then my perimeter would look like this. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so we need the... It's going to be 4 times each character minus all the shared dividers. So if there's not a point above me, then my perimeter is going to be perimeter plus equals 1. And this is basically going to be the point dot plus up point. Let's do this. Point dot up, down, left, and right. For dir in that, so if it doesn't contain my my point plus the direction, then the perimeter is +1, and we can return the perimeter. So that'll give me a B is going to have a perimeter of 8. So we'll do test of a perimeter in a box. This is going to be B. It's going to be starting at 0, 1. Then it's going to go 0, 2, 1, 1, and 1, 2. Okay. This is going to be B, 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 B. Perimeter here is 8. And that works. Okay, so I kind of want to print out these things for each one of my regions, but A and C plants are each within a region of perimeter 10. B and E are with perimeter 8. The lone D plot forms its own region with perimeter 4. Let's do C, because that's an oddball one. Well, actually, I think that's fine. The area is simply the number of garden plots the region contains. So that part is easy because now we can just do points.count. Okay, so if we go back to our example, this is going to take, let regions is this, grid.regions. Then I'm going to regions.reduce. We're going to start with 0. And then we're going to get our price and the region. The price is going to be price plus region.area times region.perimeter. And then that's going to be the total. And we can do total. So let's test our part 1 example. And we get the right answer. Okay, so now we're ready to run day 12. Okay, let's grab our input. Here's a larger example. Let's do the larger example and just check it has 1930. So that's going to be test func larger example throws let input is equal to this. And then we expect, let's let the results be try day at 12.part1 input. We expect that the result is equal to 1930. Oh no, we have a problem. Okay, we could probably figure out exactly which one it is if we have 2214. So let's look at each one of the regions. Let's see, let region price is this. Return that, and then we'll say print region with region.character plants with price Area by perimeter. Okay. Area by Okay, so we've got 216, 32 I plants. That's wrong. 4 by 8. That's this one. I have another I in here and it's not finding it. Either that or it's adding these two together, which seems weird because we should have multiple regions with I. C is also wrong. All right, let's step through this one and see why I isn't working. We'll step in and figure out what the regions are. All right, so our point is 0, 0. And we detect a region for that one. This region is R and has 12 values. And that was correct here. Okay, so now we're at 4, 0, which is this one. This detect region at point needs to look at that character I. We get all the neighbors for that point. This visited set is wrong. This needs to start at just the point. Before I make changes, though, let's continue and figure out what the actual problem is. Okay, so our points to visit are 5, 0, which is to the right, 3, 0, which is to the left, and 4, 1, which is down. So we're looking right now, pop first is going to be 5, 0. This one will be correct, so it'll add it to the region points. And then for all of the neighbors for this one, yeah, it's counting itself. This is wrong because it's not including the one we just started from. So this needs to be point. And we don't want to consider those visited until we actually visit them. I also think that this visited set can be empty, and this set can start with just the point where we want to do. Then we don't need this region point insertion because our loop is going to handle it. All right, let's run that test again. Well, we got the same result. So region R was correct. Right, it should have 12 values. Wait, 1, 2, 3, 4, 5, 6, 7, 8. There should be, oh, there's these, and then there's 3 here and then 1 here. So that's 3 times 4 is 12, yeah. Okay, so that one worked. Then we move over to I. So we have our starting point. We insert it. Then we look over all the neighbors that we haven't visited yet. Add them to the list. Okay, now our point that we're looking at should be, okay, now it's 4, 1. So we are going to be looking at this one. And then we're going to add in 3 more neighbors. 1, 2, 3. Now we're looking at 5, 1, which is that one. That's correct. This one is going to add 3 more neighbors. Oh wait, we just want, we don't want to walk the entire grid. We only want to insert neighbors if we found one. All right, now we got the right answer here. Let's grab our input for day 12. Okay. All right, continue to part 2. Elves are trying to order so much fence that they qualify for a bulk discount. Under the bulk discount, instead of using the perimeter to calculate the price, you need to use the number of sides each region has. Each straight section of the fence counts as a side regardless of how long it is. Consider this example again. The region containing A plants has 4 sides. as does each of the region containing plants of type B, C, D, and E. However, the more complex region containing the plants of type C has 8 sides. Using the new method of calculating per region pricing by multiplying the region's area by its number of sides has a total price of 80. Okay. Counting sides means counting corners, right? Looking at this one, we're counting the 4 corners. 1, 2, 3, 4. This one is 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. So we need to find any of the points where 2 distinct neighbors well, maybe detect corners for a given point. So like this one would have 1 corner. This one would have 1. This would have 1. This would have 1. We'd be counting all the corners. So this is going to be, corners is going to be a set of points. No. Set of points. No, this is just going to be an int. We're going to do a similar loop here. And we're going to check to see if the element to the left and up, so that would be okay, so that would check the top left corner. Then we need to check the top right, bottom left, bottom right. So those are just basically pairs. Point that up and left, then down and left, down and right, and up to the right. Okay, so we map those to a point. This becomes mapping this to point dot 0 and point plus $0.1 because we have 2 points now. And this is going to be count where. Corners for point. The thing that I need to be careful about is that I don't want to count the same corner twice. Is that possible? Maybe, let's see. For this one, I would start here. That would be a corner because this element, sorry, there's nothing to the left and the top, so that gets counted. There's nothing to the right or the top, so that gets counted. And because there's something down, we'll just continue. When we move here, this will get counted because there's nothing here and here. How do we detect this corner? So we're detecting these outer corners, but not these concave corners. So this is going to be something like check outer corners. Let's see, can infer contextual type. This is going to be array of point tuples, so that I can do this. This is going to return 2 points for every pair in. That's going to be pair.0 and pair.1. Oh wait, no, this is wrong. This has to be an int. The inner corner thing is going to be hard because I don't want to count that one twice. And if I'm just checking one direction and say if the one to the right is empty but the one to the right down is in the region, then I would count this corner. But then when I get to this one, I can't check up and to the left because I've already counted the corners for that one. Corners counted for points is a set of point. Maybe we need to do that. Let's see. These are going to be corners to check. That's going to be an array of point tuples. Then we can do corners to check. We're going to map this to maybe an array of booleans. So this would be that gives me an array of booleans, and now we can check to see count where, and then we have our corners, no, these are our probes. If there's, these are always going to be tuples, so maybe I just, instead of an array, we'll do that. If probes dot 0 and not probes dot 1, then it's a corner. This will be an outer corner. If probes, we can do else if probes dot 0 not equal probes dot 1. That means that 1 is in the set and 1 is not. We only want to check inner corners. So like this is an inner corner unless the point that contains it has already been checked. So I can't do this. I need to just have the points. Yeah, we're going to do, instead of a Boolean, we're going to do the actual point. Let's that's like A and B, let's say. Contains A. Then contains B. Then we're an outer corner. We're an inner corner if contains A is not contains B. That means I need to figure out which one it contains. And I want to return true, but only if not contains A or no. I need to check probe A to see if that's in the set of corners that we need to check. Corners counted for points. If corners counted for points dot contains probes dot A. Okay, if we contain A and we don't have that one in our list, or we contain B and we don't have corners counted for points that contains probes.b. So if that's, then we can return true here. Somewhere we have to, we need to decide what to do with that with that value. Corners counted for point would be added, I guess, here. Corners counted for points, dot insert point. This is going to be return false. Okay, so that is corner. This is new corners. Is that corners plus equals new corners, and then we'll insert it here. Okay. So to recap, to make sure that I have this correct, when we get to this one, we're going to check up, down, up and left, down and left, down and right, and up and right. So for this one, we're going to map that to all of the pairs of points we're going to check. And if neither contains a value, we've got an outer corner. If one of them contains a value, so in this case down and right, then we're going to check to see if we contain down, which we do, and we have not counted that point. Have not counted this point's corners yet, then we're going to count this one as a corner. So then we go down to this one. We're going to check up and to the left. Oh, I need one more check because this one is going to count that as a corner, which we don't want. So we need to check these L shapes. This is oddly relaxing and cozy. I'll keep this running while doing my work. Yeah. Unfortunately, I'm running out of time. I feel like I'm pretty close to a solution, which is exactly what I said yesterday. But somehow I need to find... I think instead of finding one where, oh, okay, these two are... I think what I want to do instead is if it contains both, but it does not contain the intersection here, the diagonal. Too bad. I'll leave a sub not to miss the next one. Thanks. Where are you joining from? Up, left. Okay, so what if I had C as point plus pair dot 0 plus pair dot 1? This would give me, for the up and left example, the Great White North, Canada. Nice. We're gonna do, so if this was up and this is left, then this would be up to the left. So what we could check is if A and B are in the set and C is not, then that's an inner corner. I think that actually helps, and then I don't think I need this corners counted thing. Okay, so If we don't contain A or B, then it's an outer corner. If it contains A and B, and not contains C, then it's an inner corner. Maybe that works. And then I don't think I need this set anymore. Corners to check doesn't need to be allocated every time through the loop. That would be wasteful. I also don't need a new set here because I'm always checking outside of my own. So I know that that doesn't contain. So that's going to be, these are all going to be points that contains. Okay, let's test. Let's test this out. So the region for C, let's copy this test. This is going to be detect a region's sides. Okay. Okay. We're going to require instead of expect because that's not the point of this test. Regions dot sides for A should be 4. Then for this one, B should also be 4. Expect regions 2 dot sides. So 0, 1, 2. Okay, so this one should have 8 sides. And then E should have, this is require, expect, sides equals 4 for that one. This is going to be E, and E is also 4. Okay. I suspect that we are double counting inner corners. So I think maybe I do need to check. Day 12 tests. Call can throw. It worked. Okay. Let's try this on our puzzle input. Day 12, part 2. So part 2 is similar, but this one is going to be taking the sides. Wait, no. Perimeter times sides. What was it? Area and 12 sides. Okay, so it's area and sides. Okay, we get 834828. That's the right answer. You are 1 gold star closer to finding the chief historian. Fantastic. I wish I had time to go back to day 11 to finish part 2, because I know that I am super close, but I am out of time. I will be back tomorrow around the same time, but I have to go to town this weekend, so I probably will not be doing these on stream. And then next week is also possibly a travel week, so we'll see. I still need to go back and finish day 9 and 11, but I don't know. We're basically halfway through the calendar, which is pretty cool. This is about where I gave up last year. I think I made it to 14 last year. Let's find out. My best one was 2022. I made it to day 15. Last year I made it to day 8. Why are these all out of order? That seems like maybe it's broken. I don't know. Hard to know, but I only got 18 stars. Last year I did it in Rust, so it was a language that I was just beginning to become familiar with. So that's probably the reason there. But all right. Thanks for joining, and I'll see y'all tomorrow.